right, so good evening. So welcome to the course 19 MW202 Manufacturing Process 1. So this is lecture 1. So lecture 1 is Introduction to Manufacturing and its classification. Now, what is manufacturing is? What do you mean by the term called as manufacturing? As is shown in the slide, you can see the manufacturing is the process of converting raw material into finished goods. So a raw material cannot be simply converted into the products. It requires some process. So the process which is involved in converting the raw material into your final product, that is called manufacturing process. So manufacturing process involves the selection of machinery, the selection of tooling, the selection of power, and the selection of labor. That is, you can see a wide variety of processes will be available in the market for making any part or for making any product. So your option is to choose a viable process, a viable toolings with a minimum power, with minimum labor to convert your raw material into your final product. Why you want to do this? If you do it like that, then only your profit or the person who is running that business, his profit will increase. So manufacturing is ultimately the selection of proper machinery, the proper tooling, the proper power, and proper labor. Can you tell me some of the manufacturing processes which you have heard? Can anyone tell about the manufacturing processes which you have come across or which you have heard?
3D manufacturing.
Okay.
Additive manufacturing.
Okay.
Moldings.
Subtractive manufacturing.
Well, I didn't get you.
Moldings.
Molding. Okay.
Subtractive manufacturing.
Casting, sir.
Subtractive manufacturing. Casting. Okay. Then molding is already told. Then forging. Yeah, right.
Sir, grinding.
Welding.
Grinding, welding. Okay.
Milling.
Pardon me?
Milling.
Milling. Yeah, right. Okay.
Sir, CNC.
CNC. Okay.
Soldering, sir.
Soldering. Okay. Okay, right. So you have told about many processes like molding, casting, subtractive manufacturing, additive manufacturing, welding, soldering, milling, etc. So we will classify the manufacturing processes into following segments. The prime or the oldest manufacturing process is the metal casting, molding and casting process. That is one of the basic manufacturing process in which majority of products are being manufactured. Then somebody have told me about the term called forging. So we will say that the broad name for that all similar processes is called metal forming. So metal casting is the first and the foremost process. Metal forming is the next process, under which many processes are there. I'll give you the list in the later classes. Then we will have the process called as machining. Machining is the third manufacturing process in which normally a casted product, will require certain finish, certain dimensional tolerances, etc. So that you will achieve with the help of machining process. So that is the third set of classification of manufacturing process. And of course, the fourth one is the joining process. So the major joining process in the manufacturing, that is welding. You will have soldering and brazing also used as a joining process for the manufacturing industries. So the basic classification of manufacturing is casting process, it's a metal casting. Then you will have metal forming. Then you will have machining. Then you will have joining process. And as somebody have told me the two terms called additive manufacturing and subtractive manufacturing, I just want to give an idea in this regard also. So majority of this manufacturing process, whatever we are so far told, that all falls into the category of subtractive manufacturing. You will have the processes like 3D printing and allied processes will be there that normally falls into the category of additive manufacturing. Now, in addition to this casting, forming, welding, machining, you will have processes like additive manufacturing. You will have the processes like that is sintering, all these things are part of. So there are plenty of processes are there falls under the manufacturing, but the common classification restrict into casting, metal forming, you will have joining, you will have machining, you will have powder metallurgy processes. So these are the basic classification of manufacturing processes which you can see for a raw material to be converted into the final product. So I'll just run a small video so that you can understand the neat classification and its method. Okay, so you have come across a small video where you can see the classification of manufacturing processes as casting process, metal forming process, welding process. You will have material removal process. Then you will have powder metallurgy products, and you will have additive manufacturing also. So you can see in the casting process, as is shown in the first figure, you have seen its description also. So the molten metal you are pouring into a mold, and you are allowing it to get solidified. And once it is solidified, you are breaking the mold to get your product out, and that product is called as casted product. And we have seen only the major classifications is only titled over there. Under casting, you will have plenty of other processes are also available. So if you want a product to be a product that we can say that if you are running something, a business or something like that, sometimes it will be a mass production one. So if you are producing a product in a mass production condition, which casting you can use? Your casted product sometimes requires additional features, that is you should have a definite finish, you should have a different, it should have a definite limits, tolerances, etc. In that case, which process you can be chosen among the casting process? So that is what we will be going in detail in the subject in the first module. Then we will have the next sub classification of manufacturing, that is metal forming process. What is the difference between a casting process and a metal forming process? So if we see the forming process, there are plenty of processes which falls under to the category of forming process. So we have seen forging. In addition to the forging, we will have the processes like drawing, we will have the processes like extrusion, rolling, bending, sheet metal operations, etc. Falls under to the forming process. What is the difference between a casting process and a forming process, or a forming process and a material removal process? Any guess?
Sir, in forming process, the pressure is applied to get the determined shape.
Okay.
Sir, in casting process, a mold is prepared and in which the metal is poured into.
Okay.
Sir, so no pressure is required in casting process.
Mm, I cannot say it completely right. There are processes in which pressure is applied in casting also. Okay.
Okay, sir.
Yeah. So if we see the forming process and material removal process, if I want to compare. So in the material removal process, you can see to that the additional material or the extra material in your material you are removing with a tool, okay, in the form of chips, and you will get the final product. Whereas in the case of forming process, no material is being added or no material is being removed in the forming process. Whatever you have the initial volume of material, that volume remains the same before and after the process in the case of forming operation. That is, there are two ways forming can be done. One is called hot forming and next is called cold forming. You will be studying that terminology, what you meant by the term called as hot and cold in your material science in detail. There is a temperature terminology is there called recrystallization temperature. So based on that recrystallization temperature only, we will be telling that whether the forming is a hot forming or the forming is a cold forming. Okay. So in the case of almost all forming process, you are applying pressure on the material and you are trying to deform it from one shape to the another. When you are trying to do like that, no volume is added or no volume is removed from the material. So in the forming, the initial whatever the raw material volume is there, that amount of volume will remains there for the final material also. So I told you in the material removal process, you will have plenty of processes like turning is there, drilling is there, milling is there. So plenty of processes are available under the category of material removal process. So in the material removal process, okay, the additional material you are removing in the form of chip. So that is not happening in the case of casting or metal forming processes. If we talk about the joining process, okay, once the parts are manufactured, okay, it has to be completely make into assemblies. So make into assemblies, you have to go for joining process. And based on the condition, whether it is a temporary joint or a permanent joint, you can select what kind of a joining process is required. You can see some cases there are threads are available, threaded assemblies are there, nut and bolt assemblies are there. Okay, so they all falls under to the category of temporary joints. So welding is a process which you are making the part into a permanent joints. That is, you are ensuring that metallurgical bonding is taking place in the welded parts or welded products. So welding is one of the common or most suitable or most you can find the joining process in the industry is welding process. So accordingly, now under the casting process, you will have plenty of operations like sand casting is there. You will have investment casting is there. Die casting is there. Centrifugal casting is there. So each type of product can be manufactured suited by using a typical process. So your job in a manufacturing industry to suit which process will be best suited to make this product, that you have to identify first. Then once you identify that, you have to see what are the process sequence which has to be followed in that particular manufacturing processes. So I'll just give you a glimpse about what are the parts or what are things you have to be think when you want to make a product, when you want to make a manufactured good. So now the basic manufacturing process, as I told you, has metal casting. So you can see a figure in which from a ladle, so that the one which the molten metal is pouring, that is called ladle. From the ladle, a molten metal is poured into a mold. And the adjacent to it, you can see a figure. Figure resembles to what? It's a figure of what? It's a figure of
6-stroke engine.
Yeah, the figure resembles to a 6-cylinder engine block. So basically these kinds of engine blocks are a casted product. Okay, this is a casted product. Once the casting is done, you will not be able to see the finish as is shown like this. So what you have to do is that you have to go for secondary manufacturing operations like machining. So if you want to have a particular finish or a particular tolerance should be there for your part, you have to go for the secondary manufacturing process like machining. So casting is a fundamental process. The casted product you are converting into the final product with the help of operations like machining. Even if I say the metal forming operation, the raw material or the primary raw material which is entering into the metal forming operation will be a casted product. A casted product will be entered into the metal forming operations to convert it into the final shape. Similarly, machining also, you will see a block like this. From the block, you will remove the material. Since you are removing the material, it is called as subtractive manufacturing. Okay, you are removing the material, the excess material with the help of a tool. That's why that process is generally classified as subtractive manufacturing. So when you are building one layer over the other of this casted block, that is called as additive manufacturing. Since somebody have told earlier, I just given the clear clarity over here. So basically metal casting is the first and the primary manufacturing process is used in the industry for making any kind of product or raw materials for the other process. You can see this using the ladle. A worker is filling the molten metal into the mold, and you can see these are the molds which are prepared, and you can see the other side, this is already the metal is already poured and it is locked, and you can see continuously the molds have been kept like this and metal is continuously melted and poured into these molds. So metal casting is the primary manufacturing process in which molten metal is poured into a suitably shaped mold, allowed it to solidify. Then you will remove all these boxes. Inside to it, it will be sand. You will break all this sand. You will get the final product out. So such a process that is called as metal casting process. So you can see plenty of applications across the sections. You can see casted product. If you talk about automobile, you can see the engine, the cylinder block, the aerospace turbine conditions, shipping, farming, everywhere the basic product you can see. This is the pump impeller. So everywhere you can see, even in the case of home fittings, medical implants, art, every section you can see the basic manufacturing process of making a part or a product as casting. So some of the detailed cases in automobile. So wheel rim. So you all the casting processes, by employing all the casting processes, a wheel rim as is shown like this cannot be made. Same way, you can see a manifold. which has got bends in all the directions. Okay, so all the casting processes will not allow you to make a product like this. Same way, radiator parts, you can see the fins, the fine fins, the gap in between all these fins are constant. So all, and you can see also the material for making that part is also shown over here. So gear house casing, so differential casing, cylinder block. So these all are some kind of casted parts which you will be using in the automobile sector. If we talk about railways and shipping, you can see rail engine frame, bogie frame, railway plate, then ship anchor fitting, ship fittings, bollard. These all things are made again. The manufacturing process is casting. And you can see the material is alloy steel here, ductile iron here, alloy steel again, cast iron here. In the previous slide also you can see aluminum alloy is there, cast iron or brass is shown. Okay, and in the next slide you can see aluminum alloy. So it is for aerospace parts. You can see titanium alloy. Okay, so chassis part is again made by titanium alloy. So impeller is aluminum alloy. Okay, so magnesium alloy. So you can see that a wide variety of material is also suited in this casting process, comprising from low melting point metals to higher melting point metals and alloys can be manufactured by using the casting process. So casting is one of the basic manufacturing process which you can see in any industry for making the parts. So defense also, some of the parts are shown over there. You can see the metals, cast steel is there, brass is there, bronze is there, aluminum alloys are there. So low melting point alloys you can see, higher melting point alloys like titanium alloys, magnesium alloys you have seen. So everywhere, so all kind of valves, okay, all kind of these kinds of pipe fittings, okay, brass pipe fittings, pipe splitters, large pipe, large cast iron pipes, okay, manhole covers, these all are made by using the casting process. Not only there, in machine tools also, compressor cases, hand wheels, spanners, shaft housing, coupling part, frame housing, all these things are made by using the casting process. Now comes into the electrical side, you can see the motor casing, generator housing, switch gear housing, your compressor case, pedestal of wind turbine, windmill hub. These all things are also made by using this made by using the casting process. Even you can see the windmill blades and windmill parts, the windmill turbine parts. Okay, they all are made of casting. Now size wise, if I say, think about windmill blade. There is a if you come across to the lathe shop, shed number 4, you can see the lathe where the entire lathe bed is a casted product. So likewise, very large lengthwise which comes in a larger components and smaller components can be also casted easily by using this casting process. So size, shape, okay, dimensions, these all things are not at all a restriction in the case of casting process. So you can see some of the industrial machines, okay, industrial machinery parts, okay, impellers, that are paper or sugar plants, mill headstocks. So basically all the parts are manufactured as casted product. From the you will be, according to your need, according to the suits, you will use the other processes to convert or to shape that into the products. So construction equipments, so farming and mining equipments. This is biomedical implants, your teeth implants, your knee implants, your hip implants, shoulder, oral implants. So these all things are all these biomedical implants. They are also casted products. And you can see the alloys is titanium alloy, titanium cobalt alloy. Here also it is titanium cobalt alloy. So you can see that from a lower melting point metal to a higher melting point alloys also can be made by using suitable casting process. Not all the processes are not suitable for all the metals. You have to take into the account. Likewise, size wise also, if we are considering all the processes are not, all the casting processes are not suitable in that case also. So you have to select the proper manufacturing process requires its finish and conditions. That is, if we see the two thin blanks, okay, its dimensional tolerance, its dimensional finishing, etc. You have to be taken care. You have to be extremely taken care. Whereas if you have seen a hand wheel in the previous slides, so if it is a hand wheel, only the outer area only you are going to touch with your hand. So that area alone needs to be smooth. Whereas in the case of teeth, that is not the condition. So accordingly, whatever your limit, fit, size, dimensions, etc., you have to select the proper casting processes. So you can see the art, deco, or jewels. They are also made from the casting. Even jewelry ornaments, gold ornaments. Gold ornaments are also made by using the casting process. So across all the sections, you can see the applications of metal casting as available. So advantages of the metal casting in general is parts both small and large of intricate shape can be produced. Almost all the metals and alloys can be cast. Faster rate of production, simple and inexpensive. No limit on size and shape of the part to be cast. These are the advantages of the casting process. Disadvantages, limitations on mechanical properties, poor dimensional accuracy and surface finish for some process, especially for sand casting. Safety hazards to workers due to hold molten metal. That is, if you have not prepared your mold perfectly, sometimes the mold may crack. When the mold is cracking, whatever the molten metal you have poured into it, okay, within a fraction of time, it will spill into the ground. So worker safety you have to ensure. And when you are melting certain metals, okay, toxics, it will generate toxic elements. So that toxic elements also you have to taken into account. Then certain cases you are melting. So obviously you have to fire it. So the NOx emission or CO2 emissions will be there. So it will create the environmental problems. And you can also see that improper mold design. If you are not designing it properly, casting defects may also occur. And if I am saying that if you want to make one or two products, okay, if you want to make only one or two products, that is not small quantities. In that case, making a mold, making a pattern, these all things is not justifiable. So these are the disadvantages of the casting process. So if we talk about the classification of this molding process, you can see that there are two types of molding processes are available. One is called as expendable mold and next is called as permanent mold. I'm not going to its details right now. We will see its details in the next classes. And these are the again based on the filling condition. So you will have mold filling under gravity, pressure, low or high, or vacuum. So these are all the ways, and you can see the pressure die casting plant at Hyundai. Okay, pressure die casting plant at Hyundai is shown over there. You can see the neatness of the floor. If you go to a sand casting plant, you cannot find this kind of neatness over there. Okay, so it depends on what the process is, what the part is, how the product you are making. Accordingly, all these conditions will vary. And somebody have told me initially that in the casting pressure we will not use. So you can see the mold is filling under gravity. It can be filled under pressure, and pressure can be low or high, or it can be filled under vacuum condition also. Okay, So these are about the filling condition. And now we will see the general steps for any casting process. What are the general steps in casting? So if you want to cast any product, first you need to melt the molten material. Then you have to make a mold cavity. So mold cavity is nothing but the replica of the product what you want to manufacture, that is called as mold cavity. Now to this mold cavity you have to pour the molten metal into it. When once you pour the molten metal into it, the mold cavity will be filled. Then you have to allow some time for the mold cavity, for the molten metal to get solidified in this mold cavity. When once it is solidified, you can break the mold. Okay, you can break the mold and you can take it out. Once you take it out, you have to clean the product and further treatments, either machining or heat treatments, you can provide it on the casted product. So these are the general steps which will be followed in a casting industry to manufacture any product. And this slide will gives you a complete idea about the available casting processes. Okay, I'll give you a detailed explanation about this in the next class. Since the time is 4:15 nearing, I'll just with this video I'll wind up the session. Then we will go for the discussions. So this is a typical condition or a typical industry layout. Okay, inside the casting, you can see the process, or you can see the various processes which are happening inside a foundry in a schematic layout. So you can see that this is the place where molding is performed. You can see it is a box of 2 boxes are there where the molding is being performed. Okay, so now the mold, one set of mold which is made over there, you have seen it is named as drag. Another one box is being prepared. You can see it will be named as cope. So molding, so in the casting, you can see 2 box molds you have to prepare called as cope and drag. And cope and drag is kept as one unit. It has been gone into the metal pouring unit. So in the metal pouring unit, the person will tilt the ladle and the molten metal is poured into the mold. So when it is pouring, you can see it will be spilled to the areas across also. So once the metal is poured, you can see it has been kept into the area where you can keep the material for cooling. You can see the molds are stacked one over the other as is shown in the figure like this. Okay, and once the proper solidification time has reached, okay, the mold is sent into the mold breaking machine. You can see it is a vibrator. On this vibrator, the sand particles are separated and your casted products are separated. The mold, the sand, you can see it will again send back into the drag or cope area. You can see it will be sent back into the drag or cope area, and it will be recycled and reused. Okay, the product, whatever is there, it will be going from there to the inspection line for the product. This sand, whatever you have seen here, it is a typical combination. It is a typical combination of a different sand. So how to prepare the sand, how to prepare the mold, what are the parts of a mold, okay, name what are the types of sand. So these all things we will detail see in the next class. So with this, I'll finish right now. We will go for discussions. I think